Okay, so as you can probably see up in the upper left, I've had the time running at some ridiculous speeds, but we can go ahead and switch that back to real time. It makes no difference either way. It's just having this time going at, like something like 100,000 times the normal time makes it kind of hard to watch for things. And I'll also go ahead and turn off the orbits for right now. So starting off, we have it just centered at the sun. There isn't a whole lot I have on this right now. I want to more focus on the planets. It's something not having to spin around. So we'll go ahead and as we get started off, head towards Mercury. So again, my name is Josh. My pronouns are he, him, his. Now, if you have any questions during the presentation, you can chat with the different hosts of the meeting. There's myself, Deanna, and Dr. Palmquist is also another co-host. And so at any point you can probably message questions. I won't be answering a lot of them until the end, but you can still send them nonetheless. So starting off, we do have Mercury, and so Mercury gets their name from the messenger of the gods from the Roman gods. Most of the planets have been named after Roman gods. There are some ones that have some Greek names as well. The mass of Mercury is actually about 6% of the Earth, so its mass is really really small. It's also the smallest planet in the solar system as well. And so I can go ahead and I can turn off the lighting and shadow so you can sort of see the behind over here as well. And so uh, Mercury is the distance that we use is called astronomical units. It's 0.39 astronomical units away from the sun. Now, an astronomical unit, essentially, the way to find that is that one astronomical unit is the distance from the Earth to the sun. And so if I remember which unit is which, I believe it's supposed to be about 95 million kilometers or 150 million miles. I believe that's correct orientation for the units. It's been a fat minute since I've checked that. But that's essentially that. So 1 AU is the distance from the Earth to the Sun. So Mercury is about 39% that distance is the way to look at that. And its orbit is 88 days. And so 1 year on Mercury takes 88 days. And so what's interesting about Mercury is it's actually what's known as tidally locked with the sun. And so essentially the same side is always facing the sun as it orbits. It's basically, it spins as fast as it goes around. And so one side is always facing towards the sun, one side is always facing away. And this creates some really interesting things with its temperatures. If I turn back on lighting and shadows, the side that receives the sunlight, the direct sunlight, it can receive temperatures that's as high as 427 degrees Celsius. Meanwhile, the dark side of Mercury, the side that never receives sunlight, can get as low as negative 173 degrees Celsius. For reference, the coldest anything can be at all is negative 273 degrees Celsius. I believe that's the number, yeah. 273.15 if you want to be exact. And so they're really extreme temperatures on both sides, but that also creates an interesting dynamic in the middle, just along the shadow. There's like a very small, narrow strip along the edges, along I think it's called the terminator, when the edge of the shadow, where it's actually habitable temperatures. So you could, in theory, have a base on Mercury along that strip, and it'd have to be along that entire area of the planet. And so that's Mercury. This it is the closest planet to the sun, so we sort of go in order. So next on, we're going to Venus, and I'm trying to fill time because it takes forever for the software to go to the different objects. And this is also on the fastest setting that I can have it on. So this is Venus. It looks a bit different than what you'd see in the photos because it actually this image has its atmosphere removed. So this is sort of a basic idea of what the surface would be about looking like. And so Venus is actually named after the Roman god of love. Its mass is about 82% of Earth's, but it's actually very close in size. Its diameter is just above 1,200 kilometers. To be exact, it's 12,104. And Earth's diameter is 12,742. So they're actually, when it comes to sizes of planets, they're actually really, really close. And so that's why Venus is a lot of times referred to as like the sister to Earth. And it's sort of like a sister planet because they actually are really close in size. However, that's usually where most of the similarities stop. Its orbit takes about 225 days, so a year is 225 days. But at the same time, a day is longer than a year. I don't remember the exact number for how many days or how long a day is compared to how many Earth days an actual Venus day is. But the result of the how fast it spins, actually, I believe it spins what's known as retrograde. So every other planet in our solar system, they all spin the same way. I believe it's counterclockwise. I could be wrong though, but they all spin the same way, except for Venus, which spins the other way, very, very slowly. And so when it spins at that, there are a lot of different theories about why it spins that way and why it spins the other direction than the other planets and so slowly. I think the most prominent one that I remember is that it's theorized that maybe some other objects hit Venus when it was still in its sort of growing phases, and the impact was powerful enough to sort of stop the spinning that it was doing and start spinning it the other way. I don't know how much backing there is in that theory, but that's the one that I remember. So it's something that could be interesting to look into for after the presentation if you all get interested. And so with Venus, another interesting thing is that its atmosphere is very thick, and the pressure that it creates is actually 92 times that of Earth's. And so things that we send to Venus, any spacecraft that we send to Venus, can't last very long because we have to specially design it for very specific conditions that are very hard to maintain. On top of it having, have the pressure being 92 times that of Earth's, it also tends to rain sulfuric acid, another thing that's not helpful if you want to send spacecraft down. I believe NASA did send a spacecraft down to get pictures, and I don't recall exactly how long it lasted, but it didn't last more than a couple of hours, if I remember correctly. It's been a while since I've read on that. I believe the first people that actually sent spacecraft to Venus was Russia, and so it's something that we don't send a lot of spacecraft to the surface of Venus just simply because it's extremely difficult. And so its temperature actually, even though Venus is closer, even though Mercury is closer, Venus is actually the hottest planet in the solar system in terms of surface temperature, at 462 degrees Celsius, as opposed to Mercury's 427 on the side that faces the sun. And so it's quick math, 35 degrees Celsius hotter than even Mercury. And that part of that has to do with its atmosphere, because the atmosphere is so thick. It actually has sort of what's called a runaway greenhouse effect, and that the heat that it takes in from the sun, it gets it trapped inside the atmosphere, and it actually warms the planet more than you would expect. And so Mercury is all around a very interesting planet to sort of try to read on and just learn more and more about, just because there are so many things that sort of extreme that you really wouldn't expect it, especially when we didn't know a lot about it. And it's named after the Roman god of love, and it really thought, because it was so bright in the sky, and that there was a lot of things that really thought it would have been like a tropical paradise, but it was really the exact opposite. And so next, I am going to touch on Earth a little bit. There isn't a whole lot we can say that we don't, already know elsewhere. I don't need, the mass is one Earth mass, things like that. But so the Earth is actually, a couple of things that are pretty interesting is the Earth is estimated to be 4.54 billion years old. It's, for the solar system overall, you'll see a lot of similar things throughout the other planets, but it's always fun to talk about this stuff for Earth. Its rotation is actually gradually slowing. So our days are slowly but surely getting longer. It's the amount that you would experience over your lifetime is completely negligible. You need, I believe the numbers I saw was you would have to wait 140 million years in order before a day reached 25 hours. So the amount that it's actually growing is unbelievably small. However, it is gradually slowing. And this is actually, Earth is the only planet that's not named after a god, as well as Earth is actually the densest planet. With its density on average, it changes as depending on how far, the depth that you're looking at in the interior of the Earth, but its average density is 5.52 grams per cubic centimeter. And that may not seem like a lot, but it's actually, that's the densest planet in the solar system, which is kind of interesting. Next up is Mars, is the one that we most wanted to go to next. And so trying to go it's the next planet we want to colonize. It takes extra long apparently to go to it. And so this is Mars. It doesn't look like much, but it's it's the next hope in where we want to go. So the mass of Earth is actually 11% that of the mass of Mars is actually 11% of that of Earth's. It's sitting at a distance of about 1.38 AU, so it's about 38% farther away from the sun than the Earth is, and its orbit takes 687 days for a full year. Now, the temperatures range on Mars from negative 153 degrees Celsius, which is really cold. It's almost as it gets to close to what Mercury had on its dark side, up to 20 degrees Celsius, which is a pretty good temperature. That's it's a bit hot for what we see on Earth, and so that's actually one of the reasons why we want to look at Mars next in terms of our colonization, in terms of our expand word onto other planets, is because the temperatures that we can see and live on with Mars aren't too terribly different from Earth's, and so it would be a lot easier to adapt to it. It has, even though it's so much smaller than Earth, I think it's about half the diameter almost, so it has a lot less surface area. It still has about the same amount of land mass as Earth because of how much of Earth is water, at least on the surface, and so it actually has about the same amount of land mass. And so one of the biggest things that you hear time and time again, and I am going to bring it up if I can find it. Let's turn off the lighting and shading for a moment so I can look for it. There it is that it actually has the largest, I believe it's volcano. I don't know if it's mountain or volcano. I don't remember. But I know that Olympus Mons is like the largest, I'll say volcano in the solar system. And so it's Mars, being one of the smaller planets, has the biggest volcano, is fantastic. It's actually so big that the slope that you would use to walk, if you tried to hike up Olympus Mons, the slope wouldn't seem like you're climbing up a mountain, and yet it still gets to the point where the elevation that you increase is unbelievable. And so it's fairly wide, and so as a result. And so it's very interesting to think that you wouldn't notice you're walking up a volcano, and yet it still gets to the it's the highest volcano in the solar system. And so we can fly right past the asteroid belts. I can at some point see if I get access to asteroids, but on the current list that I have down here, it doesn't look like it. I can also go back and revisit a bunch of the other moons and whatnot, but first I want to focus on the planets. And moving on to Jupiter. So if you don't know, Jupiter is the largest planet in terms of radius in our solar system. There is no competition. It's by far the largest. And so Jupiter is actually named after the Roman king of the gods. It has a mass of 318 Earths. Its distance is about 5.2 astronomical units. So it's a little over 5 times farther away than the Earth is. Its orbit takes 4,333 Earth days for a single year. And something, if you try looking up different facts about Jupiter and whatnot, you can actually see that there's what's known as surface temperature. Its surface temperature, what I found, was negative 108 degrees Celsius. And the reason that we have surface temperature, when I found it, I'm not entirely sure if they're referring to just beginning clouds but with the way that Jupiter and the other gas giants actually are, with the way that their structure is because they're so large. When you start getting closer to the core, the amount of pressure that's there, as well as on occasion the temperature, mostly the pressure that's there is so great that the gases will actually start to be liquids, and there's theorized that there's also some solid there as well. And so in theory, even, gas giants, in theory do have a surface. It's just way farther than you will ever be able to make it, because the pressures are so extreme that it's making gases like hydrogen and helium be liquids and solids. And so that we're decades, centuries away from technology that can be exposed to those kinds of pressures and not be utterly destroyed. And so that's just how it is with where we are now. Jupiter has 79 moons and plenty more moonlets and undiscovered moons and whatnot. A lot of it has to do with, captured asteroids and just different things going on with that, interacting with those asteroids, that it's theorized that that's where a lot of its moons come from, because its gravitational pull is so great. It's kind of it's what you get for having one of the largest masses of the solar system. And actually, Jupiter actually has rings. It actually has 4 rings. And so while Saturn has the most prominent rings, it's because it's, you're so easily to see them in the visible light spectrum of light. That was worded really badly. I'm sorry. But so all the Jovian planets, all the gas giants, they all have rings around them. It's just Saturn's are the ones that are most easily seen in the visible spectrum of light. And so they're the most prominent. They're the ones that we always think about. But Jupiter also has 4 rings. And so it's very interesting. I believe to see them, you need to look at infrared light, if I remember correctly. But it's, like a lot of the things I say, it's been a long time since I've actively looked at that information. It's just all in the back of my head. What's interesting is Jupiter actually, even though it's the biggest, it actually has the fastest day. Its day is actually 9 hours and 55 minutes. And that's the fastest out of all the other planets. And so going on to Saturn, with something, if you notice something I didn't say about Jupiter is I didn't say Jupiter had the most moons out of all the other planets. And that's because recently, and by recently I mean I think a few months, maybe close to a year, I don't know, it's been a long time. Recently, Jupiter doesn't hold that title anymore. Saturn actually, after it had more confirmed moons added to its list, now has more moons than Jupiter. And so first off, the basic stuff that I talk about on everyone, the Saturn is actually named after the Roman god of agriculture and harvest. Its mass is 95 Earths, and its distance is 9.58 astronomical units. So it's almost twice as far as Jupiter. Its orbit is 10,756 Earth days, or almost 30 Earth years to go for a full orbit. And so Saturn actually has 82 moons now. So it has 3 more confirmed moons than Jupiter, beating it out in how many moons, or who has the most moons. And so you can clearly see that, like I said, Saturn has the most prominent rings, very beautiful. What's interesting is actually Saturn's rings are actually falling in towards the planets. And so eventually Saturn's rings are going to disappear. And so that a lot of that has to deal with how rings are formed in planetary systems. A lot of times it'll be when an object, a moon or an asteroid, when it's going around the planets, if it gets too close to the planet, it reaches what's called a Roche limit, and to where the gravity on one end of the object is so much greater than the gravity on the other end of the object that it literally pulls the object apart. It pulls the moon apart. And so that's where you end up getting rings. And actually, that's actually going to create rings around Mars someday. Mars has 2 moons, Deimos and Phobos. Phobos is actually going to get too close, and Mars is going to end up having a ring system someday. And so, but Saturn is also, it's slowly but surely losing its ring system. And so I think that's all the things I had in Saturn. Moving on to Uranus. Now, Uranus is actually, with the information that I found, Uranus is actually named using Greek stuff. It's actually named after the Greek word for sky. I assume is pronounced Uranus. I know how it's spelled, but I don't know how to pronounce it. I probably should have looked that up. But it's named after the Greek word for sky, which is really interesting because I don't know if you're able to notice how blue it is in the night sky, because I know it's really faint and very difficult with the naked eye to see, if at all. You'd have to have incredibly good eyesight, as well. Yeah, and so if that, even if that, and so I don't know if the color had to do anything with how well, with it being named after, you know, the color of our sky. It could just be a lucky guess. I'm not entirely sure. It's another thing to look up if you're really interested. So Uranus actually has a mass of about 15 Earths. And so its distance is 19.22 astronomical units away. So it's 20 times almost farther from the sun than the Earth. Its orbit is 30,687 Earth days, or almost 84 years, or I actually think it's almost exactly 84 years. It has 27 moons and 13 rings. So it has about half as many rings as it does moons, which is really interesting. And it's actually, another thing about Uranus is it orbits on its side. And so in a way that it's, so almost all the planets have sort of a tilt from straight up and down from where the plane that it orbits on. And, you know, so, you know, it varies from planet to planet. You know, like with Earth, ours is around 24 degrees, and that's, you know, it's why we get seasons. But with Uranus, it's actually almost 90 degrees. I think it's like 89 point something. I don't, if I remember correctly. And so it's very close to being just literally on its side. And so relative to the other planets, and so, that's just an interesting little thing. So it's actually also one of the coldest planets in our solar system. Its atmospheric temperature at its minimum reaches about negative 224 degrees Celsius. I think it's almost around 50 degrees above the lowest point you can get in Celsius, and so it's extremely cold, and so it's like I said, it's the coldest planet in the solar system. Another interesting thing that not so about this planet but its moons is that all of its moons are named after after characters made by William Shakespeare and Alexander Pope. And so moving on to Neptune. Neptune is named after the Roman god of the sea. Its mass, it has 17 Earths. Its distance is 30.10 AU. And so Uranus is 20 times farther than Earth. And now Neptune is 30 times farther from the sun than Earth is. That's a really interesting picture. I don't know why it's like that. Its orbit takes 60,190 Earth days, or a little, nearly 165 Earth years just to go around one orbit. It has 14 moons and 5 rings. And so what's interesting about Neptune is we actually discovered it using mathematics. Astronomers were noticing that the other objects in our solar system seem to be being influenced by an object that we haven't detected or haven't detected yet. You know, it couldn't be explained by other objects that we already knew about. And so there was this mysterious thing that we didn't know about that was affecting the things. Either, you know, could have been that they've noticed something with Uranus, or they could have noticed something with Kuiper objects. I'm not entirely sure what the story is on that. I just know that, you know, they noticed that something was off, and so you know, there was a lot of math that was done to try to figure out, well, if this object is, you know, if these objects are being affected in this way, you know, what would that mean for where we could possibly find things? I believe it was a probability sort of thing, where we thought, you know, there's a chance that the object that we think is affecting this stuff could be found in these locations. And so it took a while, and we actually ended up finding it on September 23rd, 1846. But we had to use mathematics to be able to find this planet. And so it's the only planet in our solar system that was found using math. And we actually think that there might be a planet 9 out there that we can't see, literally for the same reason. We see that there's, you know, lately we've noticed that there are objects in our solar system that are being influenced in ways that we don't understand, that there's another thing missing, another big thing missing. And so there's astronomers are trying to figure that out right now as well. So it's another interesting thing that, you know, we're able to use our understanding of the solar system and use mathematics to try to find things like this. And so another thing about Neptune is it's actually also the smallest gas giant. It's also technically the smallest ice giant, because you would a lot of people call the Uranus, Neptune the ice giant, because they're so cold that they're not really ice. They're sorry, they're not. It's not really a lot of gas. And it is gas, but it's really cold gas, so they call it ice giants. And so, I'm actually really intrigued by why the image is the way this is. Usually most images you'll see are even with the ones like down here, like you see it's a lot darker than Uranus, and like you see clouds and you see sort of like some like banding in a way, but nothing to this extent, which is just has me really curious. I wonder if I turn off this so it still has this like this. That's interesting. That's actually something, this is something that I'm going to look up into after, later on the days to come, because I don't know why this is being the way this is. And so it's always interesting to look at programs like this and to be able to explore and try to figure stuff like that out. And so that goes through all the 8 planets. Now, I'm not going to cover, I'm not going to cover Pluto as it was a planet, and I will talk about that a little bit. I know I'm reaching towards the end of my time frame here, so I will be wrapping up soon. However, something that I will note is the reason why we don't call Pluto a planet anymore. I mean, in a way, we never called it specifically a planet to begin with. It was just a placeholder name we gave to everything for a while. But essentially, to define something as a planet through I'm blanking on their name, but the international group that like decides all the astronomy things. The way that that they define a planet is there were 3 criteria. 3. Haha, my hand shows up. 3 criteria is that the first one was that it has the object has to be orbiting around the sun. The second thing that the object had to meet was that the object had to be large enough so that the gravity of the object made the shape a sphere. It had to be a spherical shape. And then the third thing that it was required to do is that the planet was supposed to clear its path, that the orbit that it takes is supposed to clear other objects out of the way. How we have a bunch of asteroids, with like say the asteroid belt and the Kuiper belt, but you don't see tons of asteroids in the same orbit, areas of orbit as the other planets. You don't see asteroids that are constantly in the same orbit with Earth. You'll have things that cross the orbit, but they're never in line. They're not continuously around with the different planets. And that's actually something that Pluto does not meet. Pluto does not clear its path around its orbit, and so it doesn't meet all 3 requirements. It meets 2 of them. When it meets 2 of them, it's called a dwarf planet. When it meets 1 of them, it's called a minor planet. And so that's actually why we have something called a minor planet catalog, where it's something that it allows us to track asteroids, I think comets as well, I'm not entirely sure, but it's there's minor planets, dwarf planets, and planet planets, and that's why. And so when that official thing was put in place, that's when Pluto was named a dwarf planet. And so that really is all I have for Star Party tonight. We are, like I said, we're running a little bit low on time, and so now I can open it up for questions. And so I got my chat up on here. Thank you, Dr. Palmquist, for putting all the helpful links and correcting me in some of my questions and whatnot. But yeah, so I can open for questions now. If anyone has any. If you're also able to open up the chat, and it'll only be able to message to one of the hosts, so you can send them that way.
I'm actually going to go ahead and unmute everybody, so you'll be able to just go ahead and chat directly with us and ask questions. So unmuting everybody. All right, so if anyone has questions, go for it.
Just go ahead and read me really quick.
Josh, what's your favorite planet?
Oof. I think my favorite planet would have to be undiscovered planet nine. Simply just because it's, for me, it's the idea that there's something we haven't seen, we know is there, and we have to look for it. I have another question here. Could we see the giants with a telescope? And so it really depends on the telescope. And so when it comes to observing the different gas giants, Jupiter and Saturn, we're able to see them with the naked eye. Uranus and Neptune, I believe Uranus, even with some pretty good binoculars, you'd be able to see Uranus. It'd be difficult to find, but you'd be able to see Uranus. I believe Neptune with the with some some fairly cheap like backyard telescopes. I believe you should be able to, for most telescopes, you'd be able to see Neptune as well. It's very easy to look this up online. I don't know the answer off the top of my head. When it comes to observing objects, there is everything has sort of a measurement of brightness, what's called a magnitude. And so we have, different levels of how bright or dim something can be. Essentially, the bigger the number, the harder it is to see, the dimmer it is. And so our naked eye can go to about 6.5. And Uranus and Neptune are past that. But we also have most, when you look at getting binoculars or telescopes, or especially telescopes, most of them will be able to tell you at least roughly about like some of the dimmest objects you can see with them, or at least you can do some little research online to be able to figure that stuff out. It really depends on the telescope. And so like what Palmquist is saying, with an okay backyard telescope, you can see Neptune. It really depends on the how big the telescope is. Any other questions? Any at all? Comments, concerns, criticisms, other ways of expressing verbal language?
You did a great job.
Yeah, great presentation. Thank you.
Thank you. And while I wait to see if any more questions come in, something I will touch on briefly is, if you are interested in hearing more about these events from the Astronomy Club specifically, and you're not already receiving emails from the Astronomy Club, you can. An easy way to go about that is going to the website for Astronomy Club. I have the URL right up here, siwooastro.wixsite.com/central. Now, this is the home page. As you load it up, this is exactly what you see. If you look at any of our web pages on here, when you scroll all the way to the bottom, there's this little subscribe form thing. You put your email address in there, hit submit. It sends an email to us letting us know that you want to get information from us on club updates, whether it be, for spring quarter, it's, be able to be things like getting the Zoom links to be able to register for more of these star parties, or to participate in an Astronomy Club meeting over Zoom if you want to go out and do that. The little things like that, as well as when things start to slowly get back to normal, getting information on events that happen, both from us and people that we work with, things of that sort. If to keep updated with Astronomy Club, it's the best way to get that information, because while we do try to, I try to make sure I communicate with Dean as much as physically possible, it doesn't always work out the way it needs to. And so doing this is a good way to make sure that, to get that information.
And when is the next star party?
The next star party is, I have to look at the map because I don't remember map. I say calendar, is April 28th. It is on the, right now it is planned to be on Women in Space History. And so that one will be more PowerPoint style, but it's still an interesting topic nonetheless. And so I plan on being there at least, and I know that it'll be really interesting.
And what's the frequency for star parties?
Frequency for star parties. Glad you asked. So the frequency of star parties is they happen the second and fourth Tuesday of every month that classes are in session. So if I pull up this calendar again, So today is the 14th. It's the second Tuesday. The 28th is the fourth Tuesday. If you go into May, you can see that the second Tuesday is the 12th, and the fourth Tuesday is the 26th. And so those will also be star party dates. But if you notice that if we go into June, this is about, I believe this is still our last week of classes. This is finals week. And since we're in finals week before the second Tuesday, we will not have a star party then. So it'll just be April and May. But when you go into, say, September, maybe the 22nd, depends on when we start. But definitely like in October, you know, if you want to keep updated that long. Some people do, some people don't. But yeah, so a little bit on the software, I mentioned a little bit. So this is actually what's called Worldwide Telescope. You can see the name up in the upper left. This is actually free for anyone to download. So if you wanted to go and get the software, you'd be able to play around with it, you know, all you want, figure out why Neptune looks the way it does. But you can also play more a lot with the other modes that, you know, you didn't get to see here. I've been strictly using solar system with a 3D solar system view this entire time. And there's also a lot of things that I haven't even looked at. Like you can straight up, if you wanted to, throw up all the asteroids. And so now, you know, lift those up all the different asteroids with different dots. You know, the yellow dots are what's called the Trojan asteroids. Or you have, you know, the pink ones and the white ones from the asteroid belts. Or you have the Kuiper belts. And I think maybe a little bit of the Oort cloud. I'm not entirely sure. But, you know, different things to experiment with, and also just to have fun zooming out. Like you can totally zoom out all the way, see what we think our galaxy looks at, go even further. And even if you don't know what this is still incredible to look at. And so it's a really nice software to have and play around with, and I highly recommend it. You can also find the information on the software at the Astronomy Club website. Okay. Is there anything else?
Well, I think we are done for the evening. Thank you everyone for attending. Josh, thank you. It really was a very, very good presentation. Enjoyed it. Like you said, the next one is going to be in 2 weeks, same bat channel. The link will go out much earlier this next go round. It'll also be on the CW Physics webpage, the CW Astronomy Club webpage, as well as on their website also. So thank you very much for joining us.
Thank you.
Thank you.
Thanks.
You're welcome, Martin. How are you doing?
I'm doing all right.
Good. So how's dorm life treating you?
It's pretty cool. I got a little like Zoom setup. I moved my room around so that I can have like a whiteboard as my background.
Mm-hmm.
And
Nice.
I colored it in with a green expo marker.
You have a green screen?
Yep, I have a makeshift green screen now. I don't know if I can.
That's a little impressive.
Oh, there we go.
It's not liking it right now.
How many students are in the dorm with you?
In my hall, I think there's about 30 or 40.
I think we need to give Martin control of the screen, Josh.
I can hit remote control Martin Mates. And I think that means you can control it now. just don't break anything.
I can control it now.
Apparently.
Let's see.
Waiting
I'm gonna
for
stop
my
the
minds to
recording.
control the screen.